Alright guys, welcome back to Underground Science, and in this video we'll be talking about just a few examples of a Bronsted Lowry acid and a Bronsted Lowry base. Alright, so let's go and get started. So our first example, let's just look at a basic example. We'll look at a strong acid of hydrochloric acid, and we'll see that reacting with water. Alright, and once we see it react with water, we're going to see that it actually turns into hydronium ions and a chloride anion. All right. And so when we start talking about acids and bases, right, we have to know that since we have hydronium ions in solution, we know that we're working with an acidic solution here. Okay, so it's either H plus cations or hydronium cations. All right. So in this case, our strong acid, hydrochloric acid, is reacting with water and forming hydronium cations with chloride anions. Okay, and we have to identify which compound here is the Bronsted Lowry acid and which compound is the Bronsted Lowry base. Now, how you do this is it's just you have to look at which compound. I mean, if we're talking about Bronsted Lowry anything, then we're talking about the reactant side, all right? So as soon as you see Bronsted Lowry, it's the reactant side. Because the product side, we're going to be talking in a future video, we're going to be working with a conjugate acid or a conjugate base. So you can look for that. When you hear conjugate acid or conjugate base, it's the product side. But we know we're working with the reactant side here. And a Bronsted Lowry acid is pretty much anything that donates a hydrogen proton, all right? So a hydrogen cation is a Bronsted Lowry acid. So let's go and write that down first. So a Bronsted Lowry acid, a good way to know this is that it's any, you could say, element in a compound that will donate hydrogen protons. That's it. Will donate hydrogen protons. I will donate a hydrogen proton to the other compound in the reactant side, right? So what do I mean by that? If we look at this example, if we try to identify the Bronsted Lowry acid, we'll see that it's actually HCl. That's the Bronsted Lowry acid, because HCl turns into Cl minus. Where did the H plus go, right? Where did the hydrogen atom go? Where did the hydrogen cation go? Well, it joined with H2O, right? It transferred its H plus onto H2O, turning H2O into hydronium, right? So our Bronsted Lowry acid is the one that donated that hydrogen cation or donated that proton. And we can see here clearly that our HCl donated the hydrogen proton to H2O, because now we see here we lost a hydrogen cation. So we had to have donated it somewhere, and we donated it to our friend H2O here, turning him into H3O plus or hydronium. So here we can identify this as our Bronsted, oh my gosh, I can't spell, sorry about that, Bronsted Lowry acid. Alright, so this is our Bronsted Lowry acid. Alright, so that's pretty much it. That's all you have to look for when you're trying to identify a Bronsted Lowry acid or a Bronsted Lowry base now, which is what we're going to talk about. It's pretty much the opposite. A Bronsted Lowry base is not a base that donates hydrogen cations, it accepts hydrogen cations. Alright, so it accepts hydrogen cations. So let's go and write that down. So a Bronsted Lowry base doesn't donate hydrogen cations, it doesn't donate a proton, it accepts a proton. Alright, so it accepts a hydrogen proton, a hydrogen cation, pretty much a proton. Alright, so here, what accepts a proton? Well, we just said that we see H2O accepting a hydrogen cation from HCl. Alright, so we're accepting a hydrogen cation, our H2O is. So in this case, our H2O is going to be our Bronsted Lowry base. So let's go and write that down. So let's go and draw an arrow down here and say our H2O is our Bronsted Lowry base. Bronsted Lowry base. All right, so that makes sense, because again, let's look at the definitions of a Bronsted Lowry acid. We said it's a compound that donates a hydrogen cation. Well, here we see HCl turning into Cl minus. Where did the hydrogen cation go? It can't just disappear. Well, we see that that hydrogen cation went to the H2O, right? H2O accepted the hydrogen cation because HCl donated to the H2O, and then that caused the H2O to turn into hydronium, making an acidic solution. So if our H2O is the one that accepted the hydrogen cation, we'll be talking about a Bronsted Lowry base. But since our HCl is the one that donated the hydrogen cation, then we're talking about a Bronsted Lowry acid being our HCl. And our H2O is the Bronsted Lowry base because we see here that we accepted a hydrogen cation, H2O did. All right, so that's the basic overview of a Bronsted Lowry acid and a Bronsted Lowry base. And I just wanted to go over the basic overview so that we can understand it. We can understand the basic idea, so it'll help us later on when we talk about more about acid-base calculations, all right, and titrations and all that. Okay, so I really hope this video made sense to you guys. I hope it wasn't confusing or too boring. Make sure to tune into my future videos about biochem, and physics and chem. And I hope to see you guys there in my future videos. Stay safe. And don't forget to like and subscribe and hit that notification bell. And see you guys later.